Hello, everyone. We'll be working on another related rate problem in this video. I have done a few more in a separate videos. Please check them out. They're in the description box for you. Let's go ahead and start. So a baseball diamond is a square with side 90. Sorry, that is important information. A batter hits the ball and runs towards first base with a speed of 24 feet per second. Part A, we want to know at what rate is his distance from second base decreasing when he's halfway to the first base? Part B, we want to know at what rate his distance from third base increasing at the same moment, meaning when it's halfway to the first base. All right, so let's go ahead and introduce a variable. So let's suppose he has traveled some X distance from home to base 1. Let's call this home. This is base 1. This is base 2. That's base 3. Okay. And we know that this is a square diamond. So diamond is a squared. We know that each side, this is 90, this is 90, 90, 90. Okay. All right. So let's call this distance that he has gone some, he's going from home to some distance of X. So let's use the variable X to represent distance from home towards base 1. So at the rate that he's running towards base 1, that is going to be dx dt. It is 24 feet per second. So if this distance that he has traveled is x, which means if the entire length is 90, that means this remaining distance has to be 90 minus whatever the x he has traveled. Okay, so that is an important piece of information. Now I'm also going to create a triangle right here. So from here to base 2, let's call that my hypotenuse. So if I pull this triangle out, let me also call this z. So z will be the distance wherever he is here to base 2. All right, so we have the following triangle. Here's your sides and that hypotenuse. So we know we're looking at z right here. This distance is 90 minus x, and this is 90, of course, because this is a square diamond. Okay, so now we know we are going to be using Pythagorean's theorem since we have a right triangle. But what are we really looking for? So part A, we want to know at what rate is his distance from base 2 decreasing when he's halfway through. So we want to know what is this rate when he's halfway through the first base, when x is 45, half of 90. So we want to know what is dz dt when he has traveled halfway through 45. Okay, so let's figure out how to do this. So we know we can figure out the z value. So based on what's been given to us, so we know z squared is equal to the side length squared. So that's 90 minus x squared plus 90 squared. I can find x. I'm going to use this equation twice. So first I'm going to use it to find the value of z. Then the second time I'm going to use it is to actually differentiate this to get the rate. So we'll use the same equation twice for this problem. So let's find the z value first. I'll plug in x equals 45. So z squared is equal to 45 squared plus 90 squared. So I'm simply plugging these in. And now I'm going to go ahead and take z. Z is equal to the square root of 45 squared plus 90 squared. Okay, now if you evaluate this, you should have z is equal to about 100.62. Let's just say that. All right, so that is the z value. Now hold on to that. Let's go into our equation again. Let's find the rate. So we're going to go ahead and take the derivative of this equation with respect to t. So if I differentiate the left-hand side, we get 2z dz dt. So again, chain rule. Now on the right side, you differentiate this variable with respect to t. So using the chain rule, this is 2 times 90 minus x squared, sorry, not squared, 1 times negative 1 times dx dt. And then the derivative of 90 squared, of course, that's 0. Now let's go ahead and solve for our rate, dz dt. You can reduce both sides by a factor of 2, so I can actually cancel that out. So we have our dz dt simply is equal to everything on the right-hand side divided by z. So that's negative times 90 minus x dx dt all over z. So that's how you compute the rate at how the his distance from second base decreasing when he's halfway to the first base. All right, so we have everything already given to us. So we know x, that's halfway through, that's 45. This was given in the problem right here. And we also know z we just computed by using the same formula. So let's plug everything in. So our rate dz dt is simply negative 45, because 90 minus 45, times dx dt, that was 24. So put 24 here and divide that by 100.62. All right, so that's going to give us our rate dz dt is equal to negative 10.73 feet per second. So of course it's negative because it's decreasing. So that's the interpretation. At what rate it's decreasing? 10.73. Okay, so that's the first part of the question. Now, we also wanted to know, well, at what rate is his distance increasing from the third base at the same moment, meaning when he's halfway through. So we're going to create another triangle. So what I'm going to do, so imagine he's some distance x here. Let's say I create another triangle. So let's label this maybe y. So I want to know what is dy dt at that same instant, same moment. So let's draw that triangle out. So for part B, we have different triangle. Here you go. That's the triangle for part B. Now this distance is x. Now how do I get that? Well, if you look at the picture, we're looking at this triangle right now. So this distance is x. This is 90, and that's y. And we're looking for dy dt. So y is unknown. We know this is 90. So now let's solve for what we're looking for, which is dy dt in this part of the question, when again x is 45. So same moment as the previous part. Okay, so now I'm going to go ahead and start writing out my equation. So again, this is the right triangle. We know that we can use Pythagorean's theorem. 90 squared plus x squared is equal to y squared. Now we can go ahead and take the derivative on both sides with respect to t. So on the left-hand side, you just have 2x dx dt, because derivative of 90 squared is 0. And on the right-hand side, you have 2y dy dt, and we're looking for dy dt. Again, you can reduce by a factor of 2 on both sides. So you're going to get x dx dt divided by y is equal to dy dt. So that's how you're going to find the rate. So that means we still need to compute what y is. So I'm going to go ahead and use this equation one more time to figure out what y should be at that moment. So we have 90 squared plus x. Well, we know it's halfway through, so we know x is 45 squared is equal to y squared, which means y has to be 90 squared plus 45 squared is equal to y, and that will give you the same value. You'll have 100.62 is equal to y. And then I'm going to now make those substitution. So I know dx dt that was given to us in the problem. That was given to us initially, 24 feet per second. Let's go ahead and substitute. So x, we know that's 45. Dx dt 24. Y we just computed, that's 100.62. So that is equal to, again, 10.73 feet per second. Again, because of the symmetry of the problem, it's the same value as part A, except that here it's a negative because the distance, the rate is decreasing. Here it's increasing, so it's a positive number. All right, I hope that makes sense. Hope you enjoyed. Watch a few more to have a good grasp on these questions. Take care, everyone.